Now this is the first video from chapter 13, lesson 1. So before we start that, we're going to look at a question in 2 dimensions. So you might want to pause the video at this point and make sure that you can answer this question. Now what most people do is, to find the equation of the line, they can see that they got a point. If they got a slope, they can do point slope. So they go ahead and rearrange all this. And actually the answer turns out to be 5x minus 4y equals just a different number. There's a much quicker way of actually doing this, and we just substitute in the x and y values into this equation. So 5 times 2 is 10, negative 4 times negative 1 is 4, and 10 plus 4 is 14. So actually a parallel line to this would be 5x minus 4y equals 14. Just like that. And hopefully if you did do it the other way, you would have found out it's the same thing. Now the reason we're going to do that is we're going to do the same thing with planes in a little bit, which is in 3 dimensions. So the important part is the x and the y components stay the same. It's just the number at the end that changes if they are parallel. Now first of all, we need to know what the vector equation of a plane is. With it being in 3 dimensions, there's 3 components to it, so our x, y, and z, and then it's going to equal a specific number. So if we have a question like this, find the equation of a plane parallel to this one, passing through this point, and we can use the same idea that we used in the other question. These numbers are going to stay the same. The only thing that's going to change is this last number. So if we substitute in 2 for x, 1 in for y, and negative 2 in for z, then we can find a different value, which is 18. Therefore, our equation parallel to this would be 3x plus 2y minus 5z equals 18. So a fairly easy concept to begin with. Now we're also going to look at normal vectors, and if you can remember from our work on tangents, normals are going to be perpendicular. Now it's kind of difficult to demonstrate a plane, so I'm going to use a book to represent that. So this in theory should be infinitely big, but it'll give you some idea. So a normal is going to be something that's at 90 degrees to this plane. Now it's going to be 90 degrees this way, but also if I was to twist the book around. So I can't do something like this. So it looks like it's 90 degrees from one side, but not from the other. So luckily for us, there's a very key fact that connects these two things. If we have a plane with A, B, and C like this, then the direction vector of our normal is also A, B, C. So that's going to make our life very easy when we come to answer these questions. Just so you can see exactly what I was trying to show you with the book there, here's our plane, and then this is our normal, which is going to be at 90 degrees to that. So find the equation of a plane through this point and normal to the vector 3, negative 2, and 1. So we have a point that lies on the plane, which we're going to use in a little bit, and we also have a direction for the normal. So the direction uses 3, negative 2, and 1. And we use those for A, B, and C. So there's our general equation for a vector equation of a plane. And we know it must be the same 3 numbers as we had up here. So we can say that it's 3x minus 2y plus z equals k. To find out what k is, we're just going to substitute in 1, 3, and negative 2. And if we do that, we get negative 5. So our equation is this, equals negative 5. And that's our first 2 key skills for vectors in this chapter.